In the last video, we have written a model in this format where we have written the input, linear operation, ReLU activation, linear operation and then sigmoid. This type of writing the model is suitable only for writing the simple models. Whenever we want to define a model which are more complex, that is, which are other than a simple sequence of existing modules, in that case, we define our model by subclassing the NN module. We have already made use of torch.nn module by importing as NN and used in the last video to implement a layer like a fully connected layer like this. Model is equal to nn.sequential and inside the parenthesis we have defined the layers. This torch.nn module is not just limited to fully connected layer but also can be used to implement a convolutional layer, a pooling layer and the activation function. Apart from these, we can also use torch.nn module to implement an entire neural network by instantiating a torch.nn.module object. With the use of torch.nn.module, we can combine many simple layers to implement a complex neural networks. That is, in other words, we can use it to represent an arbitrary function of f in Pytorch. So, to summarize, we subclass the torch.nn.module to create a complex network. And to do the same, we override the methods under nn.module class. There are two methods which we can override. First is init function. This function is invoked when we create the instance of nn.module. And inside the init function, we will define the various parameters of a layer like number of neurons in input layers, hidden layers and output layers. If we are using for convolution, then we can also include the filters like kernel size for a convolutional layer, dropout probability for the dropout layer and so on. Once we have overridden the init function, then we will override the forward function. And inside this function, we will define how our output will be computed. So to make it easier to follow, what I'll do is I'll implement the same model from the last video. As a first step, I'll define a new class as custom class, and this takes in the parameter as the parent class. So inside the parenthesis, I'll mention as nn.module. And now I'll define the init method which takes in the parameters as number of units of neuron in input layer, hidden layer and the output layer. So under the init method of custom class, I'll call the init method of superclass. And this is done as super.init. And then we will simply create the model like we have done in the last video. So this would be self.model is equal to nn.sequential and inside the parenthesis it is nn.linear, number of neurons in input layer and number of neurons in hidden layer, and then nn.ReLU, and next nn.linear, that is number of neurons in hidden layer, comma number of neurons in output layer, and finally it is nn.sigmoid. So, as per our requirement, we have overridden the init function which takes in the number of input neuron units, hidden layer units and output layer units, and we have defined the model. We then proceed to override the forward function, and here we write the forward function such that it accepts an input tensors and return the output tensor. So this would be def forward self comma x, and then it is written self.model x. So the forward method accepts the input x and returns the output by making use of the model defined in the constructor. So guys, this completes the model definition with the use of nn.module in Pytorch. Once it is executed, we will create an object of a new custom class. That is, custom nn is equal to custom class, and inside the parenthesis, what I'll do is I'll pass in the parameters, that is number of input neuron units, hidden layer units and output units. Okay, this is complete. The other part of code, that is selecting the loss function and learning algorithm, remain the same. But the only modification we have to do is modifying the fit function. So I'll just copy paste the previous one and then change the computation of y hat. So instead of y hat is equal to model x, I'll change as y hat is equal to custom_n in x. That's it. We just have to pass in the input for the object of subclass which we have just created. If I now execute the code, we can see that we have the same result as before. So guys, I hope you now have a clear idea as how we can make use of nn.module to write our own class. And you will build more intuition on its working when we implement a complex network such as LeanIt architecture in the upcoming sections.